Hello, welcome back. In this video, we're going to talk about variables in the Java programming language. Variables are places in your computer's RAM or memory where you can store data in there temporarily. And, once the data is stored, you can access the data later on and use it, or you can replace the value that's why it's called variable, because you can store something and then you can replace it with something else. Let me show you how. Now, there are two steps to working with variables, I guess. The first step would be or maybe let's say three. So the first step would be to declare the variable, i.e. to say, reserve a place in memory for this type of data to be stored and associated with this particular name, a variable name, okay? And then the second thing that you can do is to give a value to be stored in that location. And then the third thing that you could do is to access that location, get the value that is stored, and then use it with something, do something useful with it. Let me show you how. So int x equals 1. And here we're going to print x. Okay, we got 1, which is this number here. Notice if you change this number here, you get 4. So what's going on? We all remember this print statement from the last videos, okay? Remember that a statement is basically some words that end with a semicolon, okay? So we see 1, 2, 3 semicolons. So we've got 3 statements here. All right. We discussed comments in one of the last videos. So I'll create a comment here and I'll call this step 1. Declaring a variable. So we're declaring that x is the name of the variable, which is a terrible name, by the way. We'll get to naming variables later on down the line. But, for now, x is fine. So terrible name, but it's okay. So x is the variable name and int is short for integer. So we have a variable of type integer that is initialized, that is given a value of 4 to be stored in it. And then here, we're accessing that value by saying system.out.println x. Does that make sense? I hope it does. So we've initialized the variable with the value 4. Now we mentioned that we could change the value of a variable because it's a variable, right? Ooh. So how do we do that? We just simply say x equals 2. And then if you print, you get the value 2 instead of 4. So what happened here is we're saying to the Java virtual machine, please allocate in memory a space for storing a value of type integer. And then please take this value 4 and store it in that memory location. And then we're saying, oh, I changed my mind. I actually would like to store 2 in that memory location now. So the value 4 gets erased or replaced by the value 2, and then we print it. So you might argue, I don't need this step anymore. And you're right. In fact, if you see the IntelliJ IDE is saying reassigned local variable. It's showing this as, I guess as a warning. So it's saying basically what you're doing doesn't make sense. This step is redundant. If you remove it, the warning is gone. All right. Now, what if you want to declare another variable? Or actually, before that, notice that we have the declaration in one line and the initialization in the other. Now, you could combine both into one line by doing this. Now, let me just get rid of the comments. So here in the same statement, I've declared a variable named x, and I've given it the value of 4. So when I hit run, 4 gets printed. And you could still change the value again, and the change will be reflected when you print. If you duplicate the print statement once right after when it was initialized with the value 4, and then you change the value to 1 and you print again, what's going to happen? Well, you will have 4, then you'll have 1. So essentially what's going on is right here, the value of x is 4. So when we got to this line, x is being read from the memory and the value being returned from the memory is 4. Now, this prints 4. All right. Now, after x's value is changed to 1, and then this is reading from the memory 1, because like we said, the value of 4 has been replaced. So what if you want to define another variable? You could just simply go and say int y equals 2. And then you can do an operation with the two variables. You can say print x plus y. So x plus y is 2 plus 4. All right. So you could do other operations like int z equals, and then instead of giving it an literal value of an integer, we could use x plus y as an expression that evaluates to a value that gets stored in z, and then we can take z, and let's say we change this to 6 and 2, the answer should be 8. Another way of defining multiple variables is to use the same statement, but to put commas between the variables you're defining. So I can copy or cut this, paste it here, and then I've defined x equals 6, y equals 2, and then z, let's change this to 4 and hit run. And the value we get is 6 plus 4, which is 10. Can I do this? Indeed, I can. And just to change the value, to see the difference, now it should output 9. So I've put everything on the same, in the same statement. So, okay, what else can we define? What else can we declare and initialize or give a value to, and then invoke here, or get the value of, and then print it? There is actually 8 types that you can work with that are called primitive data types. Now, there are non-primitive data types that we'll later on cover down the line, but for now, we're working with primitive data types. Primitive data types, now I'm looking at Oracle documentation for Java. Now, Oracle is the corporation that bought Sun Microsystems, the original company that made the Java language. So Oracle now is the entity in charge of developing and driving the Java language. All right, so just to, in case you were wondering, why are we on the Oracle page? Byte. We can define a variable of the type byte, short, int, long, float, double, boolean, and character. What is byte? Oh God, 2's complement. What it essentially is, it's an integer that is not as big as an integer. What do I mean by that? I mean, the range of values that you can represent. Okay, let me show you. So remember here, okay, let me get rid of this. I'll show you what I mean. Int x equals 128. Okay. All right, so 128. If you print that, it's going to be fine, right? It's an integer. You stored it in an integer type memory location and everything's okay. What if you change that to bytes? You're getting an error because you've provided an integer that you're trying to store in a byte. But what if you change it to 127? Well, the error disappears. Why? It does not make any sense. So let me show you just high level how this works. You got a byte, which is, like we said, 8-bit or 1 byte. And 8-bit is 8 binary digits, and each digit could hold either 0 or 1, 0 or 1, etc. Now, for the last most significant one, we're not going to use that. It's not exactly reserved for sign. Like if it's positive, it could be 0. If it's negative, it could be 1. It's not exactly that for the 2's complement. Just think about it being reserved. If you want to learn more on the 2's complement, just feel free to research it yourself. It will probably be too complicated to get into here. Yeah, so you have 7 bits that you can use to represent the number itself, and that number could be positive or negative because, like we said, it's not exactly used for the sign, but the act of reserving that bit helps us represent the sign. So what we're saying is any number that you can fit within 7 bits can be represented in either positive or negative. So the range would be, so if you have 2 digits, you could have either 0, 0, 1, 0, 1, 0, 1, 1. Okay, so this will correspond to the decimal number of 0. This will correspond to the decimal number of 1, 2, 3. And if you have a little bit more digits, then you can add 0 for all, and then you can repeat this block. Then you can change those all to 1, and then you can go from 4, 5, 6, 7. So that's how, if this looks confusing to you, that's fine. Maybe you need to take a quick course on how conversion from binary to decimal works. But the idea is pretty simple. The number of decimal numbers that you can represent using 2 digits is 4. Using 3 digits is 8. So the relationship is 2 to the power number of digits. Okay, which is here, if it's 2 digits, then it's 2 to the power 2, which is 4. And if it's 2 to the power 3, then it's 8. And you've got yourself here 8 digits. So like we said here, this one we're not going to touch, so we're left with 7 bits. So 2 to the power 7 is 128. So we can represent 128 positive numbers and 128 negative numbers. So the range, let me erase all of this.
So the range becomes minus 128 all the way through 0. So minus 127 minus 126 all the way till 0, all the way till 127. We're not going to count 128 because 0 has been counted already. So that's taken the place of 128. And that's why when if you go back to IntelliJ and you define a byte, x equals 128, and you try to print x, it's not going to work because it thinks that the number you provided is no longer a byte, it's an int. Okay, so what if you provide 127? Well, 127 works. Minus 128, that works too, because it's within the range that we seen earlier here, minus 128. Now, the same goes for short. But short is, instead of being 8 bits, it's 16 bits, or 2 bytes, because every byte, like we said, is 8 bits. So the range here, let me just get rid of all these. So we said the range for the byte is minus 128 all the way to 127. How did we compute that number? Well, it's minus 2 to the power 8 minus 1 all the way through to 2 to the power 8 minus 1 all minus 1. All right. So 128 minus 1, 127. The short, it's the same thing. Minus 2 to the power 16 minus 1 all the way to 2 to the power 16 minus 1 minus 1. Same goes for integer. Integer would be 32-bit. So it's minus 2 to the power 31 all the way to 2 to the power 31 all minus 1. The long would be, I think, a 64. Yeah, so long is 64 to its complement integer. So if we go back here, so that would mean it's minus 2 to the power 63 all the way to 2 to the power 63 all minus 1. That's our range. Okay, so let's see how we can push short to its limits. So if you search for 2 to the power 15, actually, because 16 minus 1, 16 bits here, minus 1. That would be the limit. If you take this, replace this with short, and you put that number in, it's going to complain because it's positive. But if you turn it into a negative, it doesn't complain. And if you add 1 to it or decrease 1 to it, it complains. If you change it to positive and you subtract 1, it's not going to complain. And that's basically how these containers work. So this is reserving 2 bytes in the memory, 2's complement implementation of how you can store this number, and this is the upper limit for the positive numbers that you can put in there, and we saw the lower limit of the negative numbers that you can store in there.
And then we got float and double, which are basically single precision and double precision. So these, okay, let's not get into any details. These are just floating point numbers. That's what you need to know for now. Okay. So if you have 1.12, 1.15, whatever, let's try an example. Float x equals 12.1. Oh, we already have x defined. Now it's complaining that just put f at the end. And then when you print that, so f means that this is a floating point number. If you change that to double, well, the casting system will cast that anyways. If you don't know what a casting system is, I don't blame you. It's okay. We'll learn that later on. But know that for now, double is a bit bigger than float, in the same way that short is bigger than byte, or int is bigger than short and byte, and long is bigger than, etc., etc. Now we have Boolean. Boolean can be either true or false. So if you print x, then x will be printed as false. If you change it to true and you print it, then it's true. And then character. Character is a 16-bit Unicode character. What does Unicode mean? Maybe we'll do that in another video. But what it essentially means is you can have, I don't want to use the word. So you know how we can use any name for the variable? So I'm just going to call it my variable. Okay, just to eliminate any confusion. So I'll define a character A, and then I'll print that character, and I got A printed. Print A capital, it gets printed. That's characters. So that was my little introduction to defining, declaring, and initializing and using variables, and the different types of variables that we have, the primitive typed variables. And like I said, there are non-primitive typed variables that we'll later on talk about. So I hope you learned something today. I know this was a bit chaotic. I apologize, but yeah, I did my best. So I hope you learned something, and I thank you for watching, and I will see you in the next one. Bye bye.